Hi, and welcome to our quick intro to easy dependency injection with SSW Data Onion. I'm Adam Stevenson, and I'm a solution architect at SSW and the organiser of firebootcamp.com. Let's talk about how software gets built. We see this all the time. A new project is started off and the developers go to start the first feature. They're trying to do the right thing, so they introduce an n-tiered architecture with distinct layers. Usually at least a UI layer, a business layer, and a data access layer. They add the first piece of UI. They implement security, logging, and other cross-cutting concerns. They implement a business logic component, which of course relies on the cross-cutting concerns. They add more and more UI, more services, and more data access. Now this goes great for a while, and will often get them to the point where they can release the project. Everything is good for a while at least. We often get contacted after the project has been going for a year or two. They invariably have the same complaints. It's taking much longer to add new features now than it used to. When we try to add a new feature, we have to touch lots of other parts of the system. Finding bugs is really hard because the code that we're using is very convoluted. And making changes to the system is just impossible. We don't have the ability to easily make system-wide changes to functionality or technologies. Does this sound like a project you've worked on? Let's have a look at how this happens. We say this application is tightly coupled. All the code is tightly bound to all the other code around it. Fixing bugs is hard because it's hard to track down exactly where the bug might be, because all the code is interrelated. Testing is hard because you can't test one piece of code without touching all the other code it interacts with. And making changes is hard because you can't change one piece of code without affecting other areas. Often when changes are made to one small area, you need to go and retest the whole application. So what's the answer? It's a pattern that's called dependency injection. The idea is simple and should be familiar. When you build a house, you know that the appliances in the house are going to change. You want to be able to move them around the house, and if they need a service, you need to be able to easily disconnect them, test them, and take them to be serviced. We should build our software the same way. Rather than hard-coding all of the components of our application, we build our core application around sockets that can be filled by any component that matches the plug hole. As an example, if my application is an online store, rather than hardwiring my connection to a products database table, I'd create a socket that accepts a list of products. I can plug any appliance into that socket as long as it provides that list of products. If we have a look at the business layer of our online store, instead of hardwiring in the ability to send emails, what we do is we'd add a socket that outputs messages. We can then plug any module into that socket that can send messages. Over the year, this allows us to easily extend our application to support SMS messaging, then Facebook messaging, and then whatever is the next big social media application without making any changes at all to our core application. We just build a new external module and plug it in. Choosing between which appliance or which external module to use is all done in a single line of code. Similarly, instead of hardwiring in a shipping calculation, we'd instead build our application with a socket that accepts a list of products and outputs a total price for shipping. We can build our application using the DHL shipping calculator, and if we need to change to shipping with FedEx, we can just write a new module that talks to the FedEx web services to calculate shipping costs. What's great about this is that we're building a brand new standalone module that can be tested in isolation, and when we're ready to release it, we just change the one line of code configuration in our application that tells our core application what module to use. Without dependency injection, most teams would dig through the code of the whole application, changing all the places where that calculation might have been called. At SSW, we follow a dependency injection-centric architecture called the Onion architecture. We build our applications with layers for business and data access, but instead of hardwiring any dependencies into the core application, our core application is composed of sockets. We build all of the dependencies outside of the core application and then inject them into the appropriate sockets. This gives us excellent maintainability, testability, and extensibility. You can see here we insert the email notification dependency into the iNotification service socket, the FedEx shipping calculator into the iShipping calculator, and the PayPal payment gateway into the iPayment gateway socket in the business layer. This is all very easy to set up. Next, we can see that we're mapping the SQL customer repository to the iCustomer repository and the SQL product repository to the iProduct repository. What's happening here is that we're injecting into the core application the way we query and update data. Okay, this is where people trying to implement dependency injection come unstuck. Creating sockets for data querying and updating, and then creating the external services to inject into those sockets can be very confusing. The challenges faced are that there are lots of conflicting opinions online about the right way to do it, lots of suggested methods that either require much more code to be written as the application goes along, or else they don't really provide an adequate reusable socket. We saw this so often that we've created a product to make it easy to implement and much easier to maintain injecting your data dependencies into your application the right way, the way we do it at SSW on some of the largest websites in the country. The key to SSW Data Onion is it takes the pain out of dependency injecting your data layer. You simply add a new object type, like product, and then SSW Data Onion automatically generates the socket, and it also generates the external dependency that will talk to the Entity Framework SQL database. You don't have to write all of the complex base classes and plumbing. SSW Data Onion will do that for you. I hope you've enjoyed my introduction to dependency injection and the SSW Data Onion. To check it out, go to sswdataonion.com and please give me your feedback via email or Twitter.